So we're going to talk about a few different breaches. We'll focus on one specifically. Then we'll see how that maps to the attack framework, and then how we can use Osquery to detect these types of techniques. So yeah, I'm Guillaume. My face is there, so you can know that the guy who made the slides is right here. I think they call that authentication or something. I work at Uptycs. We do large-scale security analytics with Osquery. So our agent is effectively the open source Osquery agent. So everything I'm going to say here works with the open source version. So I started working on this when I was looking at, there's too many best practices, right? You look at things like CIS benchmarks, for example. They're great, but they're like 1,000 pages long for Windows, for example. And when you look at actual attacks, well, there's a very small subset of that is usually responsible for specific techniques working, right? If you're in a defense environment, disabling the Bluetooth service on a Windows machine might be pretty important to you, but to 90% of our customers, that's not how they're going to have a problem. It's most probably going to be related to lateral movement or something like that. And that's why I like the attack framework, because that's more based on what we see day to day when doing incident response, right? So for a while, I wanted a good public breach report that I could talk about, because you can't always talk about different attacks that you see, right? It's nice when someone else does it, and then you can just reuse that and just see what could be detected with Osquery in that attack and how you could monitor these defensive controls. So we're not going to talk about any pew-pew maps. Sorry about that. We're going to start with Osquery 101 really quickly. So show of hands, who here is familiar with Osquery? And who's using it in production? All right. I think one of the reasons for that might be that support for Windows in Osquery is fairly recent, and the open source package for it used to be very bad, so people got the impression that Osquery for Windows sucked, which is not the case. So what Osquery is a cross-platform agent. Works on Mac, Linux, Windows, and also supports Docker APIs, so you can get some security events from these containers that are running without installing the agent in the container itself. And what it does is it turns your operating system into a virtual SQL database. And I will never pronounce it SQL. Sorry if anyone thinks I'm wrong. It's SQL. These 229 tables have everything from users that are logged in, processes that are running, USB devices connected to the system. It's pretty wild. And out of these tables, a lot of them work on all these operating systems. And then you have operating system specific tables. Like, for example, on the Windows side, you have tables to get authenticated data from files. You can read the registry. And for example, on the Linux side, you might be able to get information about IP tables, right? So it's cross-platform. You can leverage a lot of the stuff you're going to do on one platform across the other ones. And when you need to do something really specific, then you can do that. It's 100% open source. It uses SQLite for query execution, so it doesn't just use the same kind of language. It's really using SQLite. And the way you usually set it up is you have a set of scheduled queries, right? You say, OK, I want to know what SSH keys are on my Linux servers. And I want to know that every 5 minutes, for example. So the first time you run the query, it's going to give you the full list. And then you can do snapshot queries where it's only going to tell you if something was added or removed, which is great because you can ask the same question over and over without filling your logs if there's no change. It also has an interactive mode that you run in a terminal, which is great for developing queries. We don't really use that in production. As I said, it's cross-platform, but most of all, it's fast and it's reliable. It's coded mostly in C++, which I know can sound a little scary. Originally, when Facebook created it, the idea was we want an agent to run on our servers where if you have 1 million servers and you have a 5% impact on the CPU of these servers, that's going to get really expensive really quickly. So it's designed for performance. You can run queries that will make the system slow down to a crawl if you want to, but by default, it has its own watchdog, and it will stop executing queries. So as a security professional, what I love about that is the fact that it makes it much easier to convince operations teams to deploy it. Because by default, it's read-only, and it's really fast, and it's just going to stop itself if you're taking too many resources. So that makes it a pretty interesting proposition for ops. And then it's really flexible. It's only the agent. It doesn't come with like a logging pipeline. It doesn't come with a deployment stack or anything like that. But if you're already using Chef or SCCM, and you've already got a good logging pipeline, you can use that. You can have your own TLS endpoint for it. So it fits into pretty much any architecture. And as of last week, it's now owned by the Linux Foundation, the Osquery trademark, and it's being run by the community. So I think we're going to see a lot of improvement this year in Osquery. So it's a really good time to jump in. So a few terms we'll need to know before we go on with the attack is a query is basically an SQL query that you run on the operating system, right? Select star from processes. A query pack is just a bunch of queries with a proposed interval. So the Osquery project comes with a bunch of different query packs for detecting Mac malware, a bunch of Windows attacks, but also for compliance stuff. So it's a JSON file that has, say, 50 different queries with a specific interval. The outputs for that is usually JSON. You'll then send that to your logs, either through syslog or using something like Beats. Or Osquery has its own API for TLS, so you can talk to an endpoint and just stream that right there, which I think is awesome for laptops, because then you can selectively decide what you want to get from these machines, and even when they're out in the field, you can get just that, right? No one wants to be streaming entire Windows event logs to a SIM over the internet, but you can pick specific events and get them back from over TLS. Then we've got flags, a bunch of different configuration options. So if you hear me say flags, it's just a configuration option. Tables and events. So the difference between tables and event tables is simply that tables are a point in time, whereas the event table is a continuous stream. So for example, there's a processes table, which is a point in time. If you query that every 5 minutes, what happens if something runs in between and stops? You won't know. That's why there's a process events table that works on most operating systems, which will stream. So it doesn't build a database. It has a database for caching mostly, especially for those events, but it sends you the information back when you ask for it. So for example, you want to know if Apache is running. You may run that Unix command right there. Or you could select all from processes where the name is like Apache, and then that will give you the same result. So it gives you a standard way of asking information from your endpoints. So there's no database, but when you ask that, it's going to get the information from the operating system and return it to you in the form of either like a visual table in the interactive mode or a JSON file. So for example, that work? Okay, so I select all from the ARP cache, and I'm on the Wi-Fi right here, and you see it's well formatted like that. That's the interactive mode. Normally, you would get that back over JSON. So ARP, pretty interesting to monitor if you want to do some kind of network security stuff using the endpoint agents. So now what about those two attacks? I looked at two that were released in the last year or so. One is the SingHealth attack in Singapore, healthcare attack, that has a lot of details, a lot of information about lateral movement. It mentions exactly what application servers were being used, how the network was set up. And if you like reading that kind of stuff, I feel like this one reads like a novel. And then I looked at the Equifax one, but it's more about, oh, there's a struts vulnerability here, and then 200 pages about management structures. So I thought I was going to be able to use both, but really in the Equifax one, Osquery is not going to tell you that your management structure should be different, right? So I focus mostly on the SingHealth attack. So I know the slides are being posted, so there's a link in the QR code that totally wasn't malware at the time I made the slides. If you want to get the full report, I'll have a few screenshots of it, so I'll just leave that up for a few seconds if you want it. And since I started working on this, someone else actually wrote a blog post where all he does, Matt on Twitter, is he mapped that attack to a few different pieces of the attack framework, just missing the Osquery part. So a few key events in the attack. The first thing that happened was a machine was compromised, a workstation, in August 2017. We have a few details about how that happened, but it's not super clear. Then we had lateral movement to a different workstation, which then led the attacker to connect to a Citrix server that employees were using to access that SCM application, which was their medical application with all the personal health information. And from those Citrix servers, they then attacked the SQL database that contained all the medical records, because we think the goal of the attack was to steal all that personal health information to then find the health information of a few specific individuals. The Prime Minister of Singapore was in there, for example. And then the data was transferred back through that Citrix server. So there's probably a few things in there that we can see and monitor with Osquery. All right, so initial entry. We've got these two workstations. At the time of the report, one of them had been decommissioned for a while, so not too many details. The second one made a callback to a C2 on August 24. then we can see there PowerShell was executed, and something may have been executed by the user themselves. It's not 100% clear. We know that remnants of a public rat, they don't say what rat, but that it had password dumping capabilities, right? So probably like a modified Mimikatz kind of tool. Then the original entry point in the report, they say was phishing, but to me, if it was spear phishing, they would have found the email, right? So they haven't found the email, and there's a few people that think, and I think they're right, that it might be the ruler exploit. Has anyone here had to deal with the ruler before doing incident response? Basically a way to exploit rules in Outlook Online to execute stuff on the client that then will connect. It's been patched by Microsoft, but you know how patching happens, and also needs to be, could be turned off in some cases. So for that initial entry, looking at that C2 connection, I think socket events or process socket events is a fantastic thing to send against your threat intel feed, because you can really easily see what process is connecting where, and that lets you map it back to the process that's running, the PID of the parent. So that's pretty easy. If you already have, I don't know, like a Splunk or an Elastic you're running with all of these threat feeds coming in, you can just start correlating the two. And in this case, that C2 was reused a few times, so you would have picked it up at some point. PowerShell logging is pretty easy to do with Osquery, so I'll show a few examples. As long as you've got PowerShell block logging enabled, then it's great because you can do things like select and filter on things like specific keywords. Then monitoring the processes that are running and the parents, and because we think that it might be phishing or ruler that served as the entry point, I think that checking if Office is hardened properly is another pretty interesting thing to do. Open sockets, you just select from process open sockets. Then you have a field called remote address, and then you just map that against your threat list. But because we know lateral movement is a big problem, I like taking specific attention to ports like 445 and 3389, not against those threat lists, but to detect lateral movement. So I'm sure a lot of you work in companies or organizations that have 20 different business units. They're all using different firewalls, different endpoint tools. It becomes really difficult to enforce everything the same way. But the nice thing with Windows is it's pretty noisy when it can see other Windows machines in the environment, right? So someone goes to My Network Places, and you get that list of other SMB servers, for example. And if you think that you're protecting against lateral movement by doing things like host-based firewall to protect workstations from talking to one another, or something in your smart switches, well, you don't actually need to check the configuration of all of that all the time if you can just detect a workstation from accounting connecting to another workstation in accounting, right? That's probably not an attack, that's just noise, but it lets you detect a control that is failing. And for PowerShell, you want to enable script block logging, and then you get PowerShell events. So you can get the PowerShell events in real time from the Osquery agent, and if your endpoint is down, when it comes back up, you'll get them back. So you can get those PowerShell logging events back to a TLS server and only select specific filters. So if you don't want to stream all PowerShell activity on all workstations and log all of that, then you can build specific queries looking for things like specific tools, right? Like you want to look for Mimikatz, but if you do that, you won't catch Mimi dogs. But still, someone might be using Mimikatz and not doing what it takes to hide away. But you can also look for methods. If you're looking for methods like SC privilege enabled or token privileges, and you stream that back, then you'll have a much more narrow view into what's going on with PowerShell on all of your endpoints. And I think especially for workstations where you're not grabbing all the logs all the time, that is very useful. Osquery also has the ability to calculate similarity between events. So once you have the agent running for a while, you have a field called cosine similarity, and then you can configure the map into that in the Osquery configuration. But that's going to let you see, well, that PowerShell event that happened, how similar is it to what has been running in PowerShell since the agent started on that workstation, for example. So that's the PowerShell events table. So the osquery.io website has a really nice schema. You can see all the different tables. Right here, there's 73 tables specifically for Windows. You can see, okay, what's available on all platforms, what's available on different platforms, and it tells you, what operating system it'll work with. So I have that pinned in my browser probably 24/7. And so you can see that cosine similarity field at the bottom. So now we have a way of detecting weird stuff going on with PowerShell. You probably also want to look at the block count, because if you can monitor trends there, it can be pretty powerful, right? Like people are running simple scripts, and all of a sudden you've got like a 264 block count on a machine. That's pretty interesting, and you want to just draw the trends from that. Now, what about the parent process, right? If cmd.exe is running and its parent is Internet Explorer, I think that's a little bit worse than if a user just executed cmd.exe, for example. So the processes table has the PID of the parent, and so we can use subqueries to basically join the table with itself. So we've put a script, a little Python script on the Uptycs blog. If you want to do that interactively, just send the output to the Python script, and it'll tell you exactly what's going on, but that's not super useful in production because you don't want to be doing that manually. So what you want to do is you want to query the processes table and join it with itself. And then you want to query for weirdness. So for example, you want to select everything from the processes. Then you want to look for a specific process name. So for example, you may be looking for services.exe. The services.exe have a weird parent, right? It should probably have winInit.exe. So if I select here on this machine, the parent was 476. So when I look for select the PID name, blah, 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 where the PID equals 476, that's winInit.exe. So manually, this looks pretty good. Now, how do I automate detecting when it's not like that? Well, what you want to do is you want to select that table and then select it on itself when the expected result is not what's going on, right? So instead of doing a bunch of queries for, I want to know when winInit's parent is, when services parent is winInit.exe, you actually don't care about that, right? That's expected. You want to know when services is not being spawned by winInit. So basically, you'll do where the parent exclamation sign equal, so not equal, the process that has the name winInit.exe. And one of the guys who's really active in the Osquery community on the Windows side has actually written down a lot of these. So at Uptycs, we have a lot of that we do, but we do it more on the back end rather than at the endpoint. So if you want to do it straight in the endpoint, there's a lot of good stuff in there. And he's currently adding a bunch of Linux stuff as well. So now that we dealt with PowerShell, lateral movement, there's Office, right? So I don't know who's had to dig through Office configurations all the time. It's kind of annoying the way it's done in the registry, but at the same time, it's really flexible, right? So we have a table that lets us read from the registry, which is awesome, because everything's in the registry, or WMI, right? But Office hardening is usually done by machine and by user, and then per app, right? So you've got, the user might have his configuration, and then, / software policies, Microsoft Office 16 / Excel. The great thing with Osquery is you can do globbing, and you can use wildcards, and you can recursively look at these registry keys to find what you're looking for without having to read a whole bunch of stuff and send that back to your centralized environment. So for example, if you select it all from the registry, where the key is like HKey users / wildcard, software policies, Microsoft Office 16 / wildcard, / security, that's going to tell you all the registry keys that are configured for all the users for Word, Excel, PowerPoint, and all of that, and you can grab that back. And that lets you see keys like, that lets you see values for things like block content execution from the internet, right? Are macros from the internet going to be executed on my workstations or not? So you see that pretty easily. The problem is it's not that easy. Like if you look here, it's pretty small, but you see HKey users / and a SID. So it's not really readable if you want to know, like, oh, it's Bob. Bob doesn't have Word configured properly, and then you can figure out why. The great thing is the SID is in the registry path, and we have a users table. So that's where Osquery becomes powerful. When you merge these tables together, you join them. We can also work with strings in Osquery. We can split data on the backslashes, right? So it's Windows registry, there's backslashes everywhere, and it's actually fairly easy to know that, well, between two backslashes, there's a string, and that's the value we're looking for. So what you're going to do is select the username, the data, and then split that to get the first value after the first backslash, and you're going to call that the SID, right? So in the registry, it starts with, there's a backslash, then there's HKey users, first backslash, there's that string, that's the SID. You want to grab that as a field in your query, right, instead of getting the whole thing. And then you'll do a subquery to select exactly what we were selecting before. And then that gives you this kind of output here where I see that username G, that's my account, has the data 1 for block content execution from the internet. And I put the SID right there. So with these scheduled queries, you can get a really good stream of bad security configurations left and right, which is really powerful for tracking security hygiene. You just need to be careful when you do this in production as opposed to interactive mode like this. Be careful for the key not existing, right? Like you actually need to query, does the key exist, and not just is the key set to 1? Because if the key is set to 0 and you don't check that it exists, it might get a little bit confusing sometimes. And so if that was phishing with a malicious Office document, that would help a lot. And then if it was ruler, you just do the same thing, but you check the enable unsafe client mail rules value, and that Outlook is a certain version and up to be sure that that patch was installed. Because again, for software inventory, Osquery is amazing because you've got on Mac, on Red Hat, Ubuntu, Windows, it supports the main packaging features, but on Mac it supports Brew, it supports a lot of stuff that we all have, but that doesn't show up in add remove programs, for example. Then we talked a little bit about the lateral movement, but we didn't talk about privilege escalation yet. So that occurred over a period of 6 months. So malware was spread over shares, and weak local admin credentials or admin credentials that were stored in the clear text were used to spread that through using Citrix servers to then connect to that database server, which failed with a domain admin account because domain admin didn't have access to the SQL databases, which then forced them to find a vulnerability in the medical app to get the service account that could connect to the database. So lateral movement, we talked about that before, 445, 3389 on Windows. If you want to do the same thing on Mac and Linux, it's usually SSH that's used. And then for weak passwords, like who's using LAPS here? Local admin password solution, I think it stands for. Just a tool from Microsoft to randomize your local admin password on all the workstations and store the value in Active Directory. So I see a lot of people that deploy it, but they're not necessarily tracking that it's doing the job that they expect that it does. And then can we identify accounts logging in the wrong way? And what I mean by the wrong way is a person logging in as a service or a service logging in interactive mode, right? That's usually suspicious. So we talked a little bit about catching lateral movement before using port 445. And in the production environment, that's exactly how you would do it. Where 10.0.99 would be your management network, for example. So you probably have a longer whitelist than that. But you just want to know, is there an open socket on port 445 from anything that's not your management network or IPv4, IPv6 local host, which would indicate workstations talking to one another. And I found that to be actually doable in environments where the address space is not as logical as we'd like it to be because you can make a pretty long query and there's not a whole lot of downsides to it. And so where does LAPS come in? So we talked about the weak password, and so that's an excerpt. So the password was P@SSW0RD, which is easily cracked. So it may have been past the hash, I don't know, but for sure it's easily cracked, especially on Windows where the salt is the same on all domains and machines. But it was also stored in clear text in a few different places, even though it hadn't been used for 183 days, right? So you've got like this super weak password that's never used. So why not make it 64 character long? So if you did deploy LAPS, then you want to track to see if your policy for these powerful accounts is followed. Again, because we have the registry, pretty much everything that's a GPO in Windows ends up in a registry sometimes. And while monitoring the policies in AD is nice to be sure that people aren't doing funky stuff with them, I always prefer checking the endpoint as well, because sometimes, with inheritance and the complexity of a real production environment, it's like, well, oops, I linked this above this. I undid all that, and you'll catch it pretty easily with your endpoint agent right there. So you just want to look at that ADM PWD key, and if you want to be even more specific, you can say things like, okay, well, I want to know if the password length is less than 31 on any of these machines, and then you can track that pretty easily. And if it's above 31, then you're not generating any noise in your logs. Then we had that account connecting to Citrix using a sysadmin account. That's what SA stands for in that environment. The connection was established to a Citrix server called Citrix Server 2 from a virtual machine. And that virtual machine was also seen before as having exhibited weird behavior with the local admin account. And they believed that the system admin account would not be able to log in to servers. So they thought that these kind of management accounts didn't have interactive logon privileges to a few different servers. And it turns out it wasn't the case. They could actually log in pretty easily. So with the logon sessions table on Windows specifically, we can know who's logged in, what their domain is, as well as what their UPN is. So that's nice, right? Like you can run that all the time just to get some data back, who's logged in where. You can probably do the same with, just with logs on Windows, but this is nice because you get that nice table, which is easy to work with, to do something a little more powerful. So if you have a naming convention, I see we have quite a few customers that have like SVC underscore and that kind of stuff to denote a service account, and like ADM underscore for an admin account, or whatever your naming convention might be. There's a field called logon type in there, which uses the Windows logon types to be able to tell you, is that an interactive login, or is that a service account, or is that something that is undefined right now? So of course, you need to exclude some of the basic Windows stuff, right? Like the window manager is logged in interactive mode. That's not a real user that logged in. But because we have that, and we have the UPN and the username, we can do things like selecting and getting the results only when the username starts with SVC and the logon type is interactive. So you run that frequently, and you'll know as soon as a service account is used in an interactive manner, which might be malicious, might just be someone trying to troubleshoot something, which you probably shouldn't do with that. And then you can do the opposite, where you say, well, if the UPN is not like SVC and it's logging in as something that is not interactive, I want to know about that. And that's going to help you catch things like a sysadmin configuring a backup job with his personal account instead of a service account. And then you can clean that up. And also you can catch someone logging into your Citrix servers with a sysadmin account that shouldn't be doing interactive mode if you have like a SA underscore kind of naming convention. If you don't have those naming conventions, it becomes a little bit more difficult. You probably would need to leverage the data in Active Directory a little bit more, so send that data out to an Elastic or something like that so you can use some other fields in over LDAP. Then what about SQL auditing? Microsoft SQL, a bunch of different Microsoft applications can write to event logs, which is great if you want to grab them with tools like Osquery. My main use of Osquery for reading event logs is for workstations, because you can make a list of the things that you want and get that back over TLS all the time. But you can actually do it with anything that goes on in the Windows event log. So that's a powerful way of, from the endpoint, filtering before you send it over to somewhere else. And for example, on your SQL servers, you could grab specific event IDs related to failed logins with those powerful accounts. Though I find that on SQL database, usually you're probably grabbing these logs in some other way, and you're probably grabbing all of them. But keep in mind, this is a very light way of doing that. If you don't have a whole lot of budget for storage, and you do, but you want to get less junk for performance reasons, or just so you can keep it longer, that's like the scalpel for getting just the logs that you need right there. And in general, Osquery supports the Apple logging system, supports syslog. So on a Linux environment, you could do the same, right? You can say, well, I want to read from syslog and only send to my Osquery centralized database. It's amazing when used in conjunction with Sysmon on Windows. They're really, really complementary tools. And it's definitely one of my favorite ways of, I don't know why I wrote one of my favorite ways. It's my favorite way of picking specific logs to centralize over TLS. So, people working from Starbucks, you'll still know when those events happen. So if there's something I want you to learn from this, is that with the attack framework and open source tools like Osquery, you can take any internal incident you had, because you'll have the details because you're internal, or public breaches like that, and you can redefine what you're doing with a tool like Osquery, which is, it's almost like having a infinitely flexible EDR tool that it's not going to block anything, but it will let you read anything in the way that you want and that you need, which is very powerful to be able to build automation or pretty much anything else that you need to do in your monitoring environment. If you want to take it further than just the endpoint, well, with those ARP cache tables, and there's many different ways you can read about what's going on at the network layer with Osquery, then it becomes a really, really powerful tool. Even more so if your network monitoring is suffering a little bit from things like encryption, you don't see all the details, well, you're on the endpoint and you can see more. So these IR reports, skim them. Like a lot of them are not necessarily that interesting, but from time to time, you'll see one that has really specific examples. And to me, in the past, I was managing security engineering and blue team at Nuance Communications. It was a really good way when I saw these types of reports of understanding, are we focusing on the right thing, especially when you find reports from people that are in a similar kind of threat model that you are. And so nothing beats open security tools, right? So I think the previous presenter, Mr. Castillo, said 99 tools won't protect you, so I guess 100 will if the last one is Osquery, right? But seriously, it's about leveraging that data. So this is something that can do a whole bunch of different things, right? It can do file integrity monitoring. It can do probably a whole bunch of things that you have specific tools to do and maybe reduce the amount of complexity. And because the open source community has really grabbed Osquery from development starting from last week going on, we have the Osquery Foundation that's going to be working on this. So if you were looking at Osquery in the last year and you saw that there's not too many updates, what's going on, that's definitely going to get resolved, and we're going to see a lot more right now. And there's a few commercial companies contributing back, which makes it evolve really, really quickly. And the community is really open. So as defenders, if there's any type of data that you think would be useful for you in an incident response way, you can hop onto the Osquery Slack, mention that, and there's people looking to build new tables and do this kind of stuff that you need. If anyone's coming to Vegas and wants to learn more about that, I'm going to run a workshop at DEF CON, probably 3-4 hour long hands-on workshop with Osquery on Linux and Windows. Watch for the signups because usually they go pretty quickly. Usually happens in early July.
Thank you very much. Appreciate it.
Thank you.